So the next topic we're looking at here, go ahead and click everything closed, get all your phones away, any distractions, put those all away, please. We're going to get some review done today. So the topic for today is primarily, it's just simplifying expressions. And we'll do a little evaluating expressions, super closely related. We're going to focus kind of on order of operations first. So this is, before we jump into this though, let's just take a second and let's talk about this word, simplify. There's some words in math that we throw around a lot, and on assignments it'll say simplify this or evaluate this expression or solve. We throw those words around, and sometimes I'm not sure that students always understand what the difference is. When we say simplify in math, what are we doing? What does that mean? Yes, ma'am. One more time. There you go. Put it in its simplest form. So when we simplify something, we're not really, how do I say this? We're going to rewrite the same thing more simply. Okay, now we call these things expressions here. What are expressions in math? I'll answer that one. Expressions are just any combination of numbers and variables. It's just a thing in math that we're going to do something with. We call that an expression. In these cases, these are what we might call numerical expressions because they only have numbers in them, right? Okay, so let's take the numerical expression 10 plus 5, okay? That's a numerical expression. I've got two numbers and I'm doing something to them. I'm adding them together. There's an operation there. Simplify that, please. What's 10 plus 5? 15, right? The simplest way to say 10 plus 5 is with a single number, 15. With numbers, if we have a bunch of numbers and operations, well, we can just do all the operations and come up with typically just a single number for our answer, right? So in all of these cases we're going to look at where I've just got a bunch of numbers that are strung together with different operations, adding, subtracting, multiplying, dividing, and exponentiating. And I guess we take maybe some roots in there too, and maybe we do some absolute values. We do all those operations, but in each case, the simplest way to write all this stuff is just as one number, and that's our goal, right? Okay, but to get there, we kind of have to organize our thinking a little bit. So everybody just kind of take a second and look at that and tell me what is the correct answer to that? It is -2. That's right. Okay, the answer is -2. Okay, but you're able to do that because you already know some things about how we do operations in math. There's an order to it, isn't there? Order of operations. And you guys already know some stuff about that. If you didn't know some stuff about that, this would be a little confusing. If we were talking to somebody that before they ever did algebra, maybe, they might look at that and one person might say, okay, well, 10 minus 3 times 4 equals 7 because 10 minus 3 is 7 times 4 equals 28. And that might be a perfectly valid guess for them because how do you read a book? From left to right, don't you? So you might look at that and say, oh, okay, well, we do the stuff on the left first. 10 minus 3 is 7 times 4 is 28. But of course, that's wrong, right? We know better. We know that we have to do the multiplication first because that's what our order of operations tell us. And so we get 10 minus 12 equals -2, and that's correct. So let's just kind of quickly remind ourselves about this order of operations stuff. How do we know which operations to do and when do we do them, right? Because it can get much more complicated than this. So we're used to this order of operations tree, right? How many people, so this says GEMDOS, which is fine. I kind of always have said PEMDAS. Which way did, PEMDAS or GEMDOS? How did you learn it? PEMDAS. Okay, well, that's fine. We can make this G. It could just as easily be a P. It means the same thing. P stood for parentheses, but we always understood when we did parentheses really just meant grouping symbols. Usually it's parentheses, but not always, right? It could be other grouping symbols. And so it gives us our order. Grouping symbols first, or parentheses first, then exponents. And roots, by the way, are included in exponents. Same thing, okay? After that, we do multiplication and division from left to right, and then addition and subtraction from left to right. Now, I want to just, there's one little point here I want to emphasize. When you learned PEMDAS, did you write it like this? You wrote it horizontally like that? Okay. We don't want to write it horizontally. We want to write it vertically. So we're going to cross that out. So we're not going to do it that way anymore. Did you write it like this? Okay, you wrote it like that? What's wrong with that, though? Something's wrong with that. Something I really don't like about that. What do you think? Yes, sir.
It goes addition, then subtraction, where you should have addition and subtraction.
Okay, good. Yeah, so look at at these parts down here. This seems to imply that we go grouping symbols, exponents, then multiplication, then division, then addition, then subtraction. Not true, right? What we really want to do is parentheses, exponents, the multiplication and division, the M and the D have to be on the same level because they're equivalent, right? Neither one comes before the other. Really what we do is we just go from left to right, and we take care of all the exponents from left to right. Then we do all the multiplication or division from left to right, whichever comes first. And it might be division before multiplication sometimes, right? And then the A and the S have to go together on the same level also. Okay, so we write it like this with the M and the D together, okay? All right, so let's just look at some examples here, some sample problems. Let's take something like this. And I would encourage you here to always, at least until you really get, kind of some extra practice here and you're feeling on top of this stuff, just write down the order of operations tree. So it reminds you the order in which we're going to go through this stuff. Okay, so what comes first here? What are we always looking for first? Parentheses. Okay, we want to look for some grouping symbols, right? Okay. So are there any grouping symbols up there? Absolute value counts, right? Absolute value, that's grouping stuff together. Okay, so we've got this first layer. We'll make that purple. We've got these grouping symbols. It's absolute value. So we've got to simplify everything inside there. Okay, well, what is the absolute value of -8? It's 8. Okay, so the first step is this is just going to become an 8, right? And then we've got 4 cubed minus 8 times 6 divided by 16. And we don't really often write, for the purpose of this example, you might get some problems on the assignment like this, but we never really want to use a division symbol. We always want to use a division bar, okay? But we'll leave it like this for now. So then exponents, good. So then we come down to exponents. Well, there is an exponent here, isn't there? We've got 4 cubed. What's that? 64. 4 times 4 times 4. So that gives us 64 minus 8 times 6 divided by 16. So technically, what comes next? Multiplication and division. Okay. So multiplication and division. Well, we got to go left or right. So what's the first thing we encounter? Multiplication. Okay, so then we got to deal with that part, don't we? So that's going to become a 48. And so we've got 64 minus 48 divided by 16. What's next? Okay, now we got division. 48 divided by 16 is 3. And then finally, what's our last step? Subtraction. 64 minus 3 equals 61, and we're done. Okay, give me thumbs on that. Okay, good. So that's ringing a bell. Okay, so practically speaking, I know we're just kind of looking at just this one example, but it's just a template. It's just a way for us to talk about the concepts. Could we have done this maybe a little quicker? Okay, we probably could have, right? So if we take this example, I'm going to rewrite it over here. So 4 cubed minus the absolute value of -8 times 6 divided by 16. Okay, one thing we could do is if there are no parentheses enclosing subtraction and addition, we can always kind of just like maybe make a little dashed line there wherever we have a plus or a minus. And we know we're not going to get to combining all this stuff by addition and subtraction until the last step. So if we want to speed things up a little bit, we can kind of deal with some things at the same time. Like maybe we could say stuff like this. Like we know the absolute value of -8 is 8, right? We know that's going to be replaced with an 8. And maybe we could just do the 8 times 6 right away and get 48. I know I've got a minus there. While I'm at it, that 4 cubed is separated from all this other stuff by the dashed line. So we could simplify that term. The terms are the things that are being added or subtracted. They're the things that are separated by plus and minus signs, right? We could turn that into a 64. And really, we've done kind of 3 steps in one then, haven't we? We did the parentheses step, we did the exponent step, and we did our first layer of multiplication all in one big step, right? And then what's left to do? Well, then I could just do this division and get 64 minus 3 equals 61. Do you get the idea of that? When you're separating things by pluses and minuses, you don't have to, you can just kind of work on each of those individually until you have to get to the end and either add or subtract them, okay? If you're ever confused about that, it's all right. You can just strictly follow the steps. If it just takes a little more writing is all, maybe a little more time. Okay, let's try another one. So how about one like that? And those are supposed to be brackets. Okay, practical question. Why would we include brackets with parentheses sometime? And there's no real mathematical important reason. But why would we use brackets here along with parentheses, do you think? Because they mean about the same thing. Yes, sir. Okay, good. Just because visually it's not so confusing, right? It's a lot more confusing if you have parentheses and more parentheses. How do you know which ones go with which? Yes, ma'am.
I was going to say because the whole problem has a exponent of 2.
There you go. Okay, and we know we have to enclose that stuff because we've got a squared there. We're squaring the whole thing. So we need to enclose it somehow. Because we've already used parentheses on this inside layer, a lot of times we'll use brackets the next layer out so we know which one goes with which, right? Now, how many different grouping symbols do you see in that equation? I'm asking not even how many do you see, how many are there in this problem? Okay, 3. And let's go ahead and just kind of hit those 3. So we've got, what's the inside? We always want to work from the inside out when we have bunch of grouping symbols, when we have nested grouping symbols. So grouping symbols inside other grouping symbols. We start at the inside and work our way out. What's the furthest inside? What's the innermost grouping symbols? Absolute value, right? So that's going to come first, isn't it? So there's the first one. We'll make those blue. What's the next one? Okay, parentheses. So we get parentheses next around those. And finally, what's the last one? Okay, the brackets. Good. Okay, so there's 3. That's right. There are more, though. Can anyone think of any more that we need to include? Okay, good. The fraction bar. Whenever we see a fraction bar, we know that there are going to be grouping symbols around everything in the numerator and everything in the denominator. And I could put parentheses again, or if I want to, I could even use another kind of like a script bracket, or I could just make it parentheses again. But I've got orange parentheses around everything on top and everything on the bottom. I'm grouping all that stuff together, right? So there's lots of layers to this, lots of different parentheses. So when we follow PEMDAS, and let's do that. Whoops, well, here, I just made my own. Broke my own rules, didn't I? Okay, so there's PEMDAS, so parentheses. First layer is we've got to take care of the innermost parentheses, so the first step is going to be blue. Okay, well, what's negative 6 plus 2? Negative 4. And what's the absolute value of negative 4? Okay, so we could replace all this stuff right here with a 4, couldn't we? There's our first step, okay? So then what have we got? Well, we've got, whoops. I guess I should keep the color coding here. I'm not going to write the orange ones anymore because we know they're there. They're just implied, okay? Okay, what's next? Purple or red? Red. Okay, so we got to go red too, don't we? Okay. So next step would be red. So inside, we have to simplify everything inside the red parentheses. Okay, well, inside the red parentheses, I'm just going to follow regular order of operations. So what would I technically have to do first? The square root, because that counts as an exponent, right? It's exponents and roots. So I would turn that into a 3. There's no multiplication. Then I would come down and do addition, and I would get 4 plus 3 is 7, right? I'd get from the red. Okay, now while we're doing this, though, let's think ahead just a little bit. When we're doing problems that involve a big fraction bar like this, we're going to do everything on the top, follow order of operations on the top, get one answer on the top, do the same thing on the bottom, get one answer on the bottom, and then the very last step is we're going to divide those out, right? So we might as well be working on the bottom also. So down here on the bottom, what's the first thing I would do? Exponents. Okay, so I'm going to turn, while we're at it, we can turn that 3 cubed into a 27, right? So on the bottom, we're going to get 3 minus 27. What's this giving us? Okay, so then we get on the top, we've got our purple brackets, we've got our 15 minus, this ends up being a 3, and we're squaring that whole thing. On the bottom, we've got 3 minus 27. Okay, well, we're still dealing with grouping symbols on the top. Did I make a mistake? Oh, I did. Sorry, that's supposed to be a 7, isn't it? Whoops, my mistake. Let's fix that. So 4 plus 3 we said was 7, didn't we? There we go. Good. Okay, so now we're still dealing with parentheses. Now we've got our third level of parentheses. 15 minus 7 is just 8, right? So on the top, I'm getting 8 squared. On the bottom, I'm done. 3 minus 27 is what? Negative 24, right? Okay, finally on the top, I got one more step. What's 8 squared? Okay, good. So we're getting there, right? Now we get our answer is 64 over negative 24. Well, what are we going to do with this negative sign? Here's how I think it's the best way to deal with this. We never want to have a negative on the bottom of a fraction. You could put it on the top, or even better, put it out front, but you never want it on the bottom. So we always ask ourselves when we get to this step, positive divided by negative is negative. So I've got a negative sign out front, and then I've got 64 over 24. Well, we just need to reduce that fraction. What's the biggest number I could divide into both of those? 8. Good. 64 divided by 8 is 8. 24 divided by 8 is 3. There's my answer. Okay? There's a lot to that, but if you carefully follow order of operations, you just get where you need to be, right? Okay, give me thumbs on this. Okay, good. All right. Okay, so next issue on the assignment is evaluate expressions. Okay, so evaluate, let's talk about that real quickly. Let's talk about that word. Value in math, it gives it a weight because evaluate contains the word value. Value in math means number, just that simple. Like if you want to know what's the value of pi, well, it's 3.14159, blah, 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 right? A value always means a number. So to evaluate means you're plugging the numbers in and seeing what you get. Okay, value for number. So let's take an example. Like what about something like this? We have the expression 3r minus 4s, but we want to evaluate this when r equals 5 and s equals 2/3. So what are we doing? Substitute. We're just plug and chug, right? We're just going to plug those numbers in for the variables, and then we're just going to, chug through the math and see what we got, okay? So we end up with, if r is 5, if r is 5, then we're going to get 3 times, now here's a little trick that I always want you to do, because it may not seem like a big deal, but I promise it'll help. Whenever you're evaluating expressions, wherever you're going to plug in a value, always put parentheses there. So you're going to dump the value into the parentheses for that variable. Why do we do this? Well, here's when it's going to be valuable. You're going to run into some instances where you're plugging negative numbers into complicated expressions where you might have exponents and things. And if you don't put the parentheses there, you're going to make lots of mistakes when you do that. So always put the parentheses there. So what used to be in r becomes in parentheses the value of r, which is 5, minus 4 times, we open up a set of parentheses for s. S is 2/3. And so there's the evaluation part. Now we just have to simplify a little bit, right? Well, we know 3 times 5, that's easy. That's just 15 minus, how do we multiply 4 times 2/3? What do we do with that? I know this is just like pre-algebra stuff, but it's been summertime, we've been away from this. How do we multiply a number times a fraction? Oh, okay, good. We make the 4. Let's make the 4 over 1, and we multiply, it's easy to multiply fractions. We multiply fractions straight across. Good. So we just multiply straight across, and we get 4 times 2 is 8 on the top. 1 times 3 is 3 on the bottom. Good. And now we've got 15 minus 8/3. Okay, last step. How do we add or subtract fractions? What do we always have to get? Common denominator, right? We got to have a common denominator. Well, my denominators right now are 1 and 3. Remember that the common denominator is the least common multiple. Least meaning smallest. So we want the smallest number that both 1 and 3 divide into. Well, what is that? What's the smallest number that both 1 and 3 would divide evenly into? Does 3 divide into 1 evenly? It does. See what I'm saying? Like we can try them out and see. Well, if I choose 1, 3 doesn't divide into 1 evenly. I'm left with a denominator. 2, well, we can try 2. What about 2? Well, 2 divided by 1 works. 1 divides into 2, but 2 divided by 3 doesn't work. What would it be? It's just 3, isn't it? Yeah, just 3. 3 divided by 1 equals 3. 3 divided by 3 equals 1. So that worked, right? Those are checks. Okay, so the common denominator, and that's a tricky one in a way, because it's almost tougher to think about if one of the numbers is either 1 or 3. If I had said 2 and 3, you all would have told me the right answer. What's the smallest number 2 and 3 divide into? 6, right? The smallest number would be 6. Okay, and when we say least common multiple, here's a way of representing that. Like if I wanted to find, for example, the least common denominator of 2 and 3, here's how I could do it. I could start with 2 and just list all the multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8, etc. What about the multiples of 3? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, etc. Well, what's the least, meaning the smallest, common multiple, meaning the same multiple? It's 6, isn't it? What? Right? Does that make sense? Okay. So that's what's going on in your head when you're finding, common denominators. If we did 1 and 3, well, if I have 1 here, well, 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. Well, then it would have just been 3, wouldn't it? Right? Everybody see that? Okay. Questions? Thumbs? Good? Okay. All right. So we need a common denominator of 3. I've already got a 3 here. What do I have to do to the 15 over 1 to get a 3 on the bottom? Multiply, say, by what by 3? Top and the bottom. Okay, now let's take just a second and let's discuss that. So I'm going to multiply the whole thing by 3 over 3, aren't I? Okay, now this goes back. I want to think about, draw your attention back to what we did last week. What is 3 over 3? That's 1. 1 is our identity number for multiplication, isn't it? Right? What did we say about that? The identity property for multiplication said, if I want to preserve the value, right, of something, preserve the identity of something, I multiply by 1. Well, we're not trying to change the value of this number. We're just trying to change the way it looks, right? So it's when we multiply by 3 over 3, it's a really sneaky way of using the identity number. I end up with 15 times 3 is 45 over 1 times 3 is 3. But it's still 15, isn't it? 45 divided by 3 is equal to 15. This is just a better way of writing the 15 because now we have a common denominator of 3, right? And so we get the answer is, that's a minus sign there, I wrote over the top. On the bottom, we know that we're going to get 3. That's my common denominator. Well, 45 thirds minus 8 thirds is how many thirds? 37. That's it. Okay? I apologize. I mean, I know I went way back in time there. If I didn't mean to, you guys probably all knew all this stuff, but I just wanted to take a second and review it, before you jump into the math assignment. Okay, let's try real quick one more of these. How about this one? And the instructions here are to evaluate. I think when you see evaluate problems, you're just kind of thinking, yeah, that's good. Those are easy. Some of the easiest kinds to do in math are evaluate problems. Just plug in a value and see what you get. So here it's telling us evaluate when x is negative 6 and y is 8. Okay, so then that's just going to give us the absolute value of, if x is negative 6. Okay, so when I'm plugging in, what do I always include? Parentheses, right? Always include parentheses. Here's why. So I've got negative 6 squared minus y is positive 8 squared. Okay, try this on your calculators. Do this either on your phones or you can use Desmos online. Just use your phones. Just take out the calculator and do this. Do negative 6 squared, and I'm going to prove my point. What does your calculator tell you when you write it like that? Negative 6 squared. Negative 36, right? But is that what we're supposed to get here? No, it's not, because we're squaring the number. When you do this on your calculator, what does your calculator think you're doing? Your calculator's smart. It knows order of operations. It's going to follow order of operations, and it's going to think, okay, first I'm going to do exponents. So I'm going to square the 6 and get 36, and then I'm going to multiply by negative 1 and get negative 36. That's not what you wanted to do, though, is it? Right? What you really wanted to do was square the number negative 6. Negative 6 times negative 6 is positive 36. So how would we have to rewrite this to get the correct answer? If I want to square a negative number on my calculator, what would I have to do? I have to put it in parentheses. And I guarantee if you do that on your calculators, it's going to tell you 36. Okay? So there is a little shortcut here that I would recommend. Whenever you are squaring a negative number ever in math, and you're using a calculator to do it, what should you just do instead to make it easier? You could put parentheses there, but that's a lot of buttons to push. If I'm trying to find out what negative 91 squared is, what I would type on my calculator is 91 squared. You see the point? If you're squaring a negative, you know the answer should be positive, right? So don't even bother putting the negative in there. Just put the positive part when you square it, okay? So then this is going to give us, okay, plus we had a minus x, which is negative 6, times y, which is positive 8. And now we can just simplify this thing. Well, we've got grouping symbols, so inside the grouping symbols, negative 6 squared is 36, right? So that's going to give me inside a 36 minus 8 squared is 64, correct? So then I get the absolute value of what's 36 minus 64? Negative 28, right? That's supposed to be a 6. And 36 minus 64 is negative 28. Notice the red and the blue make purple. How about that? That's what they teach you in teacher school, how to do that kind of stuff. No, they don't. Minus, and then while we're at it, because I've got a minus sign there, I might as well do this stuff too. Negative 6 times 8 is negative 48. Got to put it in parentheses, right? And then finally, what's that going to give us? Well, the absolute value of negative 28 is 28, right? What happens when I subtract a negative? Makes it a plus, doesn't it? And here's how you can write that. Subtracting a negative minus a negative makes a plus. 48, and our answer is what, 76? Got it. Okay, good. All right, questions? All right. I'm going to, come on. I'm going to skip this one for now. If we have time, we'll come back. But the last issue we have, very last part of the assignment is probably the easiest part. Simplifying expressions that have variables. Now, what we would call, remember before I said that these were, where were they? Clear back here. We called these numerical expressions because they only had numbers. This isn't a huge deal, but I just want you to kind of hear this vocabulary. These are all examples of algebraic expressions, like that right there. Algebraic is just an adjective that we use in math. How come that's algebraic instead of numerical? What does it include that makes it algebraic? Variables, yeah, right? Think about in math, it's when you start to use variables, then the classes start to be called algebra, right? Okay, so all we do with this, super simple, all we're doing here is we're just going to simplify like normal, but eventually we're only going to be able to add up certain terms because they have variables in them, right? So let's look at number 16. What would I have to do first? Well, there's parentheses, right? Inside the parentheses, 3n minus 7. Can I combine those? They're not like terms, so I can't do anything. Okay, so there's nothing to do in the parentheses. If we're going through our order of operations tree, so we cross that one off. Okay, there was no, there were no parentheses to deal with. What's next? Do you see any exponents? I don't either. No exponents. What's next? Okay, there is some multiplication. There is some multiplication, isn't there? What do I have to multiply? Okay, good. I'm multiplying the 2 times this quantity, right? So how am I going to do that? Distribute, right? I got to distribute. When I'm multiplying the 2 times the 3n minus 7, I've got to distribute the 2, and that's going to give me what? 6n minus 14. Everybody agree? And then finally, Last step, I'm just combining like terms. I can't combine stuff with not like terms. And so what have I got for like terms? Well, let's do the variables first. I've got a 6n plus a 19n. What's that add up to? 25n, right? Okay. I've got 6 of those things plus 19 of those gives me 25 of those n's. What about the other stuff? I've got a 13 minus a 14 minus 1, and we're done. Okay? Good? All right. When are we out of here? 05. You know what? I'm going to stop. That's a lot of talking today. I'm going to stop. Why don't you guys jump in and see if you can see if you can make it through the e-ticket. You don't have very much time, but it's only like 4 problems. See if you can get through as much of that as you can. I just want to make sure everybody is on the right track with this stuff.